Welcome, Black Hat attendees. Thank you for taking time out of your busy agenda to join this conversation about detecting lateral movement. My name is Mark Durrett. I am with Stamus Networks, and I'll be your host for today's session. In this talk, Phil Owens, the Stamus Networks Director of System Engineering, will share practical insights on how practitioners can use their NDR to detect lateral movement in an enterprise. Let's first take a look at lateral movement and why it's important in cyber attacks. Top athletes understand the importance of being able to move laterally to evade a defender or mount an attack on goal. Similarly, cyber attackers nearly always use lateral movement to avoid detection and expand their footprint within a target environment. The good news is that in most cases, your network can be leveraged using a modern NDR to help detect lateral movement before too much damage has been done. Before we bring on Phil, I'd like to take a moment and introduce you to our company, Stamus Networks. At Stamus Networks, we are relentlessly focused on helping enterprise security teams know more and respond sooner with insights gathered from cloud and on-premise network activity. Founded in 2014, we are a fast-growing startup with a global team and a global growing customer base. We are exhibiting this week at Black Hat, so I invite you to please take a moment and stop by one of our booths, either the virtual one or the physical one. And now I'll turn it over to Phil Owens, who will take us through the remainder of the material. Phil?
Thanks for that introduction, Mark. Glad to be here with everyone, talk about lateral movement and how you might be able to detect that through an NDR. I'm going to go through this with a use case of someone in accounting getting popped. No offense to the accounting folks that are watching this. So this is through a phishing email, right? And the attacker will use this host machine as a beachhead to explore other network assets, right? So they're out there looking for other network assets, high value targets, vulnerable targets that might be there. As the attacker is going to be searching, they're going to find the local domain controller. We will see this machine advance through later stages of the cyber kill chain. The actual accounting machine we'll watch go through the cyber kill chain. Using standard protocols like SMB, RPC, DCE, RPC, attackers can start to move laterally. They use these types of protocols and services in order to try to maintain a low volume of alerts that might be happening from an IDS, for instance, that might be monitoring the traffic. They also use these types of tools to try not to get a endpoint protection solution to block them. And also, as well as any EDR that might be on the box, just to try to keep the visibility as low as they can. So this will allow the attacker to execute commands and move files to a domain controller. And as you might realize, a domain controller is a pretty high value target in most situations. And then now that we have the accounting machine and the domain controller, we'll all the way to actions on objectives is what we'll see within the cyber kill chain. So before I actually jump into the demo, what I'd like to do is talk a little bit about the Stamus security platform and what it is. So we talk about NDR, but in fact, the Stamus security platform kind of handles three different solutions, point solutions, if you will. It is a full-on IDS. We don't hide the fact that we have Saracata under the hood. So it's got a full-blown IDS right under the hood. Now, some of the advantages to that is you have historical evidence about known attack vectors. But as with any IDS, even Saracata in our platform can generate a lot of alerts, right? So some people call that an alert cannon. Now, we've done some work to try to keep that lower, and I'll explain that as we get into the demo. next point solution is a network security monitoring solution. We actually grab all of, well, grab the protocol data, flow information, so network flows, protocol transactions. We can actually do some packet capture as well as file extraction, so that files can be utilized within a sandbox for either static or dynamic analysis. So this is great for forensic evidence, right? And enrichment, so lots of enrichment to alerts that might be firing. But it's still not real-time detection, right? Not really actionable. The next phase is the NDR part, where you have some machine learning, anomaly detection, automated responses, and then also auto asset identification. So, the ability to figure out passively what something might be, and we'll see that in action in the demo as well. Now, this is great for anomaly detection and visibility, right, into encrypted traffic, because we will be able to create things like beaconing through TLS. We'll find that. We can also find JA3s, JA3S hashes, and things to be able to handle encrypted traffic. However, an NDR all by itself is really limited from an evidence perspective, and a lot of NDRs are kind of a black box. Again, we don't hide anything from you, and the Stamus security platform actually handles all three of these types of point solutions. And we get hunting filters, host insights, which I'll show you as well. Declarations of compromise, which is where we're going to actually start in our demo, and custom algorithms that can be utilized to find things. All right, so what you're looking at here is the operational center within the user interface, and this gives us some key indicators like how much traffic was analyzed. So in this case, 34 megabytes over the last 6 hours in our demo environment. That generated 3.8 thousand events. Now, an event can be an alert, but it's also those network protocol transactions and flow records that I talked about from an NSM perspective. The alerts, there's 931 here. So like I mentioned, an alert cannon from an IDS, you can see that. But what we've done is actually created something called our declarations of compromise. Now, what this is it's a correlation as well as automation of the data that's coming in to try to narrow things down to actual threats on assets. So in this case, you can see there are 7 of them. Now we have 6 threats on 2 assets. The reason there's 7 declarations is because one of those threats is on both of them. So the definition of a declaration of compromise is a threat on an asset. Now in this case, in the center, we have the Lockheed Martin cybersecurity kill chain, and we actually plot the assets in that kill chain. Now, in this example, these assets have already gone all the way through to actions on objectives. So what I want to do here is actually go down to the impacted assets so that we can see a little bit more detail of what's going on. Now, I mentioned that a machine, so Zaragoza's WinPC, who's coming in through VPN, right, in the accounting department. And then we can also see that Marlo Zaragoza is actually the last logged in user to that machine. Now, all of this was received from data on the network. So we don't have any agents deployed anywhere in an environment. We can also see that this next one, we have what we call roles, and this next asset, 10.7.5.5, is actually a DHCP server as well as a domain controller. So this gives us a little bit of an idea. Now, what we've done is we've actually passively identified these roles for this device. Now, the device above says it's unclassified because it really doesn't fit into anything. It's a end user PC coming into a VPN. So we're not going to classify it as a DHCP server, domain controller, or a printer or things like that, which is what we're really looking for to be able to classify items. Now, we do give a little bit more information in here with regards to metadata, as well as what methods actually caused any of the threats to fire. So you can see all of that data in here. So that's again just a little bit more detail that you can dive into on this screen. Now, the next screen that I want to look at is the timeline screen, and from here I can actually zoom in And as I do that, we can see what's taking place. We can actually walk through the kill chain. So I can see this asset, which was the Windows PC, has gone from delivery to command and control to actions on objectives. And then while in actions on objectives, we can actually see some lateral movement that is taking place within the environment. And I'll show you that in just a couple of minutes. Now, this screen is really good for walking back to patient zero, if you will, because we can see how everything moved around. And we also know from the previous screen that this is our domain controller. So from here, what I'm going to do is actually jump into our Enriched Hunting section. And that's set up here. And what I've actually done is created a filter just because we're here to talk about lateral movement. Now I can clear this filter out and we can see all the data that has taken place in the last 6 hours on this environment. And there's those 931 alerts and all the different things that we can see from a IDS as well as NSM. So metadata, we got the network data, target networks, that's that enriched network definition information. We also have some organizations. So you can see there's lots of different things that we can look at here, and we can actually create filters on to be able to see what's going on in each of these cards, right? So we can create these filters. With that, I'm going to clear this. And again, going back to the lateral movement, I've created a filter so that we can get back to that. This has a source of the user PC and a destination of the domain controller, and we can immediately see that there was SMB executable file transfer information. We can see the service controller, right? Remote control services being used. This was a close. Here's the open. We have a couple of different items here. Now, these things that you see with the SN in front of them, SNMS, SCMR, right? That service. We have a whole bunch of those that we've actually implemented within our IDS. We've created these rules specifically for lateral movement and being able to see what's going on. And that's actually, they will be delivered as part of the solution should you decide to go with the Stamus security platform. Now, the one that's really interesting to me here is this file transfer. And what I can see is they used SMB to do that transfer. I can actually click into the alerts, see the 8 alerts. Then I can actually see the synthetic view here of all the metadata that's associated with this particular alert, including the SMB information that was here with a printable payload. Now, it did say that it was a file transfer. So if I look at related events in this area, what I will notice is I can see all the related alerts, but I also have this related file info. Now, we could have set up this signature to actually save or extract the files. I didn't do that in this demo environment, but what I have done is made sure that when it does see files in the file info, I can actually get the SHA-256 or MD5 hash of that file. And if I were to take this, copy it, and take it over to VirusTotal, for instance, I can actually do a quick search and see, is this thing bad? And here we can see that it is bad. It looks like it's coming back as TrickBot by a bunch of different vendors. All right, so that in a nutshell is how you can actually see lateral movement within the Stamus security platform and other NDRs, utilizing information that's on the wire. So one last piece of data, if we look here, we can actually see each of the timestamps of when the item moved through the cybersecurity kill chain, right? Along with new TLS agents that were there. We can see here an HTTP agent of test, which might be of interest to me. And if I go to the domain controller, I can even see DCERPC information that has happened before the actual exploit utilizing Eternal Blue. Thank you for your time, and don't hesitate to come over and visit us. We're in booth 3017. I will be in the booth some of the time, most of the time probably. So if you want to come and say hi and say that you saw this, that would be great. Have a great rest of your day.